So let's talk about vLayer. Who heard about vLayer before? Oh, just one person. Excellent. Oh boy, oh boy, oh boy. All right, so you're gonna be really excited. Who's a Solidity developer? Who develops? Everyone, almost everyone. Awesome. So guys, vLayer is bringing 4 new features to Solidity. Not 1, not 2, not 3, well, 4. So time travel, teleport, web proofs, and email proofs, all right? So before we go into the features, let me explain you a new execution model. So if you're familiar with ZK or you know blockchains like Mina or maybe like Alio, that already might look familiar to you. So we have 2 new smart, 1, 2, 3, that's okay? Just checking. Now, but now, can you hear me? They say they can't hear me. I'm getting extra 2 minutes for those sound issues. All right, I can go? Awesome. So, Prover is a smart contract, Solidity smart contract like any other smart contract, but you execute it off-chain. Verifier, on the other hand, is a normal Solidity smart contract that you execute on-chain. And whatever you calculate in Prover, you can take the results and put into Verifier so that you can use those results on-chain. Let me explain. So, yeah, and the important thing about Prover, it has all the superpowers. So, this is a Prover, looks like normal smart contract. It inherits from the base contract called Prover, and you can see it's using setChain ID, and I'm gonna explain in a few slides what it means. But you can think about it as, yeah, that's actually just teleport feature. So we're teleporting to Ethereum to block 122929922, and then we check the balance. The next call, after that, we're gonna check the balance of the NFT. In this case, this is Board Yacht 8 Club NFT, and we can see what the owner, whether this person was the owner of the NFT. But I want to draw your attention to what we're returning here, and what we're returning here is a pair. We return a proof of execution, and we're returning address of the owner. And then we go to Verifier. And Verifier is a smart contract like any other. It inherits from Verifier. And it takes 2 arguments, proof and address. So those are exactly the same arguments that was returned by the prover. And it has this magical modifier only verified, which makes sure that the 2 arguments that it takes are the result of the execution of the prover. And that's pretty much everything you need to know about Prover and Verifier. So now we can go to the superpowers, and we're gonna start with time travel. And already you get a sneak peek of it. So we have this function called setBlock. It has a single parameter, which is the number of the block you wanna time travel to. And the next call after this specific setBlock gonna be executed in the context of the chain as it was at a specific block. Does that make sense to everyone? Easy peasy, right? So here's an example. Let's say I want to prove on-chain that someone is a hodler. I time travel to a very old block. I'm time travel again to another block that is old, but not as old as the first one. I take the balance off at both of those blocks, and I return the minimum, and that is considered the hodl amount. Yeah, the second superpower is a teleport, very similar to time travel, but now I can teleport to another chain. And I do it with a setChain function. SetChain function has 2 parameters, chain ID and block number I want to teleport to. And the following call after setChain gonna be executed in the context of this specific chain of this specific block. So this is even so precise that it runs different hard forks if I teleport to or time travel to a specific hard fork. All right, so here's an example of a method. What it does is I can calculate the balance of an account across multiple chains, right? So in this case, I'm aggregating the balance from Optimism and Base for a specific account. All right, 2 more to go. So web proofs. And let me start with an example because it's a little less intuitive to think about the web proofs. So web proofs are like private oracles. So you can get a private data onto the Solidity smart contract. And here's an example. Let's say you are a real-world asset manager and you want to issue token. Maybe it's a gold token, or maybe it's a stable coin. So if I want to issue mint a new token, I first need to go to my bank, and there is a special extension involved. So you go with this extension, you go to your bank, you get your balance on the account, and you hit that generate proof button. And when you do, the proof is generated. You go back to your application, you hold your proof in your hand, and now you can submit an issue token. Does that make sense? Of course, someone can have $1 million on the account, issue a lot of token, and then spend the money. So you probably want to do it periodically, and real-world assets will never gonna be fully permissionless. But with this technology, we can make them much more close to trust minimized solutions versus what we have today, which is, you have to trust the manager of the token that he's honest. And another interesting examples are Web2, Web3 markets, where you can use Web3 code, when you can use smart contracts to trade things in the real world. And one very specific example I'm going to explain is building an on-ramp when you're basically trading tokens for fiat money. And the way you could build it, and there was a team that already innovated on it called ZK-P2P. So what you do is you start your transaction, you go to a bank, you actually do the transaction in the bank, you send the money to a specific bank account, and you generate a proof that the money was transferred. And after that, you go back to your DApp, and inside your DApp you can claim your tokens that were stored in the smart contracts. Does that make sense? Easy peasy? Yeah, so here is an example code for the web proofs. So this specific code, what it does, it basically allows you to mint an NFT with your Twitter name. So this is in Solidity. You get the web proof, the content of the page. In this specific context, we would like to go to Twitter account, to the settings, where it stores your handle. And then you can, using special precompiles for JSON, you can get the username from that. And that way you can prove your own specific Twitter account. Boom. As simple as it is. So, yeah. So web proofs allows you to do private attestation, or you can think it as a private oracle. There is a JSON precompile for parsing JSON. Some other precompiles might be coming for HTML or whatever else. And there is a web browser extension that you can use to obtain. So you configure the web extension, you tell the web extension what you want to get, and you go through all those steps. And here's how you do it. You simply create a web proof, you put your own logo there in the extension, and then you can just tell, this is the starting page we want to start with, this is what you expect user to do, and then when the user is in the right place, the proof gonna be generated automatically. Does that all make sense to you? All right. So let's go to the last superpower. The last superpower is email proofs. So that's very similar to web proofs in a sense that you can take your data from the email and use it on-chain. So here's the first example, wallet email recovery. So let's say you want to recover, you lost your private key and you want to recover your wallet. You probably need to use account abstraction for it, or you need another type of smart wallet. But what you can do, what you can build with that is you can have this website where you go and you say, hey, I want to recover my wallet. This is the address of my wallet. This is the new address. I would like to have control over my wallet. You hit that confirm button. It sends you an email by the wallet recovery service. And this email has specific structure, a much specific template. And all you need to do is reply yes. You reply yes to this email, and everything happens under the hood. In Solidity, you can verify the authenticity of the email, and you can recover this wallet permissionlessly. Yeah, and I'm gonna also go back to real-world asset example to give you a little bit of a comparison. What are the differences and similarities between web proofs and email proofs? So let's say you want to issue a gold token that is a stable token tied to gold. Right? So it happens that in many countries, you need to have a custodian, and custodian needs to send you updates about what is your state of your custody. So, and most of the time they do it with emails. So this time you're gonna need a plugin for the email. So you go to the admin panel, you go to your inbox, you find around the email, and you need this special button inside your email client. You hit that button, generate the proof, and you know the rest of the game. So how does it look from the code perspective? Well, it's very simple. You just provide unverified email. There is a special method called verify that allows to verify authenticity of the email. It's fairly simple because all the emails are signed by the mail servers. So we just verify if the signature is correct. And yeah, and then off you go. You can start parsing those fields of the email, whether it's from, subject, body, and we give you regular expression precompiled, so you can do it easily inside Solidity. All right, so yeah. It's very easy to install. You just install vLayer, you just download vLayer app, you install it with vLayer app, and then you can vLayer init -- template. And we have a template for web proof, email proof, time travel, and teleport. So you don't need to build it from scratch. You can start from the example. You don't need to do the photos. The only photos you need to do is of this address, book.vlayer.xyz. So this is where the documentation is. We have getting started, every single feature explained in detail, including all the parsing stuff for JSON and regular expressions, all the different nuances you need to know, and I wanna just draw your attention to chapter 4, which has all the information about how to use it from JavaScript, how to run proving, how to run browser extension, and all that stuff. Yeah, and verified data is not our new original idea. You might have seen some verified data like ZK TLS, ZK email, or coprocessors. So I want to mention all the things I ain't gonna be talking about today. So this is all the things you don't need to know and care about when you're using vLayer. So you don't need to know cryptography. You don't need to know what our prime fields and elliptic curves are. You don't need to learn new languages and what circuits are, what guess IDs are, and all that stuff. You don't need to know what DKAM records are. You don't need to know what the storage proofs are and Malcolm mountain ranges. You don't even need to really deeply understand how the Ethereum works. In a sense, you know, what are the headers, what are the slots calculation. Maybe some of you were on one of those presentations when people doing cross-chain stuff, and you know, there is a 10 minutes presentation explaining how it works, and then another 30 just on the slot calculation. So you don't need even to know how to do ABI. Whatever prover is returning, you're just flashing to the verifier, and it's done. That's all the ZK knowledge you need to know. And you don't need to know you don't need to study fancy architecture diagrams. So if you've been in the space for a while and you might stumble upon one of those diagrams, each of this diagram is taken from the beginner section or installation sections or how it works sections. This is not advanced diagrams in the architecture chapters. So this is our architecture diagram for comparison. And how we're doing with time, we still have 5 minutes, so we're talking about the most important thing of the day, which is the bounties. We have 10,000 in bounties. 4,000, this is new technology, a lot of new possibilities. People are discussing what you can build with that, but we think we're only scratching the surface, and there's gonna be so much more to build that we didn't even think about. So the biggest bounty, $4,000, is for most inspiring use of vLayer superpowers. And there is also 2,000 for the best use of web proofs, 2,000 for the best use of email proofs, and 2,000 for the best use either time travel or teleport. Alrighty, and we have merge bounties. So Polygon is one. So there is super exciting stuff that Polygon is doing, and we're super excited about all the different ideas, how it can be used on Polygon. So take a look at that. We love Polygon, guys. Hope they love us. And yeah, so here are some ideas. Here is more ideas how you can use vLayer with a Polygon and how you can grab those merge bounties. And we also have merge bounties with Circle. We love Circle. You can see in our examples, we use USDC all the time. So there is 2 bounties we think they're gonna be especially interesting for doing merge bounties with vLayer. Yeah, thank you. And we're ahead of time, 3 minutes. Maybe there are questions. Yeah, let's talk about web proofs. I'm gonna repeat the question, sir. No worries. So the web proofs. Let me go. Yeah. So there are significant limitations and things you need to be aware when you build. It's all in the documentation, but I'm gonna mention it specifically. So first of all, your web proof, you want it to be small. 1 kilobyte is great. 10 kilobyte is fine. Everything over few dozens of kilobytes is probably too big because there is a huge overhead. There is a multi-party computation algorithm happening under the hood, and it has 1,000 overhead. So it means for every kilobyte you want to prove, you need to send 1 megabyte of data over the network. This is getting better. Early next year, we should be having 100 times overhead, so 10 times faster. But it's never going to be super fast because it's advanced cryptography, and it's going to take time to optimize, and it's never going to be, one time. So that's one thing to know about. Second thing to know about, we provide JSON precompiled for parsing JSON. So in theory, you can parse HTML, you can parse XML, whatever else. It's just the JSON is that we support initially as the most popular and important format to use. So you probably want to use for those JSON-related things, or for those pull requests. Not pull requests, but those JSON, those AJAX calls that returns data in JSON. So most oftentimes when you have single-page applications, that's where you get this data fairly easily, right? Under the hood, there are some pull requests. And one thing to remember, there's a lot of confusion, I think, about web proofs. You can think about it as a private oracle. So when you have an oracle, it allows you to get data from the public sources. The big innovation of the web proofs is you can take this data from your bank account without risking your private data, right? So for example, there is a special way to redact security sensitive data like session keys, right? So this is the power of the web proofs. You still need to trust, like you need to trust Oracle, you need to trust a notary, which is basically a private oracle. So that's something to keep in mind. Of course, you can run a network of notaries, and we are building, people are building, we are building that. So that's going to happen. But yeah, this is the security trust assumptions that's important to remember about. One last very quick question. Very fast question. I have a question. You want to build? You want to get some of those sweet bounties from vLayer? Yes. Woo! Thank you very much, guys. See you on the judging.